let's just show you so you know what I'm going to be using to type these in here quickly. So you're going to see these are all like fraction answers. So just FYI, I think it's easiest to type them in. I don't know what's up here from another class. I like to type them in using alpha y equals and pulling up the fraction bar. So in my y equals menu, that would be the style I would do it versus division symbol. If you do the division symbol, you have to have parentheses around the top and the bottom. If you don't, it could affect the order of operations and then hence your graph. So I am going to type some in for you today, okay? I can complain about Texas Instruments. I already feel I'm psyching myself up for my rant on that. But anyway, I'm going to use alpha y equals just so I don't have to worry about any sort of order of operations issues. Okay, so to get us started, here we go. You are going to see some expressions like these today. We're going to be drawing the graphs of these. And one of the things we need to talk about is when fractions are undefined, because that affects our domain, and that will also affect our vertical asymptote. So you know this. Fractions are undefined when you have 0 under the line. So don't overthink it. Look at A. What number is the only number you could not use for x? -5. So if I were to actually be doing the graph of that, there's my domain, all real numbers, x can equal -5, and I would have a vertical asymptote at -5. I'd have a line I'm not going to cross or touch because that makes your fraction undefined. All right, B, x can equal what? 7. 7 minus 7 makes 0 under the line. Now see, there's actually two answers for it. And of course, you know, I love to factor. Just slaps you in the face when you least expect it. We can factor, multiply to 12, add to 7. I'm just going to jot it underneath 3 and 4. So what are your two values you can't use for x? You got it. So like I said, we are working our way up to drawing the graphs of these expressions. So we're going to talk about domains, which is really what we just kind of did. I would just write all real numbers in front of all those so they look pretty. And then of course all of these values are going to be our vertical asymptotes, our lines we won't cross or touch when I start drawing the graphs. Okay, so we're going to do, I already kind of rambled about domains, but we're going to do some more of that. We're going to talk vertical and then horizontal asymptotes. And then I'm also going to show you some of them have a slant, a diagonal line that kind of is a boundary to help draw your curves here today. So let's first talk about vertical asymptotes. So you can see at the top a rational function, of course, written as a fraction. You can't divide by 0. Denominator can't be 0. We just talked about all of that good stuff in the warm-up. Now, that is also your vertical asymptote. So align the graph approaches from the right or the left. Very simple. You find it by setting the denominator equal to 0. So kind of like what we were just working on. So I always start with my vertical asymptote. That relates to your domain, kind of a 2 for price of 1 here. In the graphs, it's, even on your test, you'll see, they ask you for different things. Meaning some ask for domain, some ask for range, some don't ask for that stuff. Some ask for an x-intercept, some ask for a y-intercept, some don't. So you just have to look closely at the different pieces of information that they're asking you for today. Now, horizontal asymptotes take just a smidge more work than vertical. So how you're going to take a look at your horizontal asymptotes. So line the graph approaches, of course, it's going to be horizontal. We're not going to cross or touch it. How you determine your horizontal asymptote, you have to look at the degree. The degree, the highest exponent of the top, the numerator, versus the denominator. Now, you're comparing top and bottom. So we have 3 different situations that could happen. Top could be smaller, they could be equal, or the bottom could be bigger, okay? So we have all these different choices. Top could be smaller, they could be equal, top could be bigger, all these different choices that we need to account for. Now the easiest one, the degree of the numerator is smaller than the denominator. So let's say you have like an x squared over an x cubed. The degree of the top is smaller. That's what we're looking for. This is my favorite because you don't have to do any work. It's just automatically the line y equals 0. Like it, like it, like it. Now, what if I get fancy and I'm going to make the degrees be the same? Thank you. So I'm going to change this, the squared, I'm going to go to a cube. Okay, make them x cubed, x cubed. Now I know that's 1. I'm going to throw some numbers on here. I don't want to just have x cubed over x cubed. That would really just cancel out. So when they are the same. So I'm looking at the 3's. It is what we call the ratio, fancy word for a fraction, ratio of the lead coefficients. So much vocabulary here today. So for instance, this was my problem, degrees are the same, cube and cube, so your lead coefficient on the top is 2, the lead coefficient in the denominator -1. I did not write that messy, come on smartboard. And obviously I would simplify that, and that would be my horizontal asymptote. Now, if the degree, and we will see this today and deal with it, if the degree of the top is larger, maybe the green fractions flipped, x cubed over x squared, that kicks us into what we call a slant asymptote, which will be super fun for us to find because that's going to require our skill set of long division, my friends. Because remember, the looks on your face is great. The fraction bar, remember, means divide. Now, I might be able to do synthetic, I suppose. I shouldn't just say long division for it. We might be able to do synthetic. It just depends on our divisor. But to find the slant, we're going to have to actually divide it out. So prepare yourself for that. That's towards the end. Okay. Now, the other last thing before we actually start drawing these graphs, you could have what we call a hole in the graph, a point discontinuity is its fancy name. And I will show you there's a separate zoom menu you have to use to actually see it on your graph, but I will show that to you. The hole exists when you have a common factor. Oh, there's that. I should wear my taller shoes. Common factor. You got to factor out the top and bottom. And of course, to find that hole, you're going to set your common factor equal to 0. So let's say you factor it out and you have an x plus 2 and an x plus 2 in the bottom, top and bottom. That means there will be a hole in the graph. And we will see all of this good stuff, and I will show you how to find it all. All right, let's start with some graphs. Let's do it. Now, starting easy. Can you type that in your calculator and take a look at it? Sure, do it. I don't care. It's some random curves. You'll see we're going to get it drawn. Now, for the following, we want asymptotes, if there's a hole in it, and of course the graph. I know these don't ask for domain and range, but like I said, you'll see on the homework and the test, some ask for domain and range, some I might list a bunch of other stuff they don't ask for just for the love of math, okay? Let's start with vertical asymptote. Now, I always set the vertical asymptote, that's the easiest one. You just set the denominator, x squared, equal to 0. And we can solve that in our head. We would square root it. Of course, plus or minus 0, it all just boils down to 0. So I'm going to draw a dashed vertical line. I'm not going to cross or touch it. That's my excellent artistic skills for us today. Then I'm going to do the horizontal. Now here's where you're comparing the degree of the top versus the bottom. The denominator is super easy to see. Your degree is a squared. I'm just going to kind of circle that little square down there. You do have a degree of the top. Now think about this. You got to be good with exponents. 1 is equivalent to x to the 0 power. So I'm thinking of 1 because I want it with the variable x on. I'm like, okay, x to the 0 power. So 0 versus 2. Whenever the top is smaller, our favorite of them all, I don't have to do anything. It's just the line y equals 0. My favorite. So that's why I don't have any work for that because the degree of the top is smaller than the bottom. And I'm going to draw that line on too. Okay. Now, can you punch it in your calculator, get some points off the T-chart and draw it? Sure. Go for it, okay? I'm just going to go old school and make a little T-chart by hand here. And I'm not going to get too carried away on this because it's a fraction. 1 over x squared, you get a lot of crazy fractions. We all know our drawing skills here. I just really can probably do it off 2 points. If my asymptote's at 0, I'm just going to pick a number on either side of 0. And I'm going to plug those in and see what I get. So let me erase because I've kind of written all over this little function here. If I put -1 in for x, -1 squared 1. So I have -1, 1. I'm going to plot that. I'm going to draw the curve off that point in a second. I'm going to put 1 in. 1 squared, of course, 1. So you have the point 1, 1. And yes, you can get those off your calculator. So all it is to draw it, you're going to have these curves that get close to the horizontal asymptote, close to the vertical. close to the horizontal, close to the vertical. If you graph it, you'll see some lovely curves like that. Now, a little better drawn curves than that, let's be honest. Okay, here's my rant on Texas Instruments. If you type that in your calculator though, it will not draw the asymptotes for you. So just to, I'm not gonna type them all in, but let's do this guy. So I'm doing my alpha y equals and my 1 over x squared. So if you take a look at it, God, I hate Texas Instruments. I'm gonna complain about this so much. I know, I'm gonna try not to. I hate a lot of things about this graph because I look at that, does that look like it's hitting the x-axis, this picture? Yeah, sure should it be. Sure should it be. And if you look, of course, in the table, it just makes me so mad. Why can't we get better technology? If you look in the table, you can see all your y coordinates are over 0. They're all, yeah, they're fractions, whatever, but they're all positive values. They are above 0, which I just told you what the range is. I'm gonna list for fun too. So, oh God. And then of course it does not draw the asymptotes on here. So use your calculators, yes. I like it for a T-chart. Sometimes I don't want to take the time to do all the calculations, but don't heavily rely on the picture. Okay, I can't look at this. I gotta delete it. It's giving me anxiety. All right, now, we answered everything. There's not a hole in it. There was no factoring to do anywhere, canceling. For fun, what if they asked you for domain and range? We should be able to do domain and range. Well, domain and range, of course, domain, left to right, x-axis. Your domain, super easy, relates to your asymptote. We're all the way left, bam, I can't hit this red line, then we pick it up, it goes all the way to the right. You can use everything but your asymptote. All real numbers, x can't equal 0. If it asked for domain, if it did, it doesn't, I just, love the math here. Range. If I asked you for the range, I'm looking at my blue curves and I yammered on about how I hate Texas Instruments, we're all above 0. So I'm just gonna say y is greater than 0. Or you could do interval notation 0 to infinity if you wanted. This isn't a very exciting one, but what if it asked you for an x-intercept? Does it hit the x-axis? No. Does it hit the y-axis? Oh, okay, all right. So just FYI. Same old, same old. Just if it asks you some other characteristics. So nice, easy, basic one to start with. All right, let's take a look at this guy. Now, first I'm looking at it. Be nice if we could cancel something out, but I can't because you have the plus and the minus. Plus on the top, minus on the bottom. They're not the exact same thing. There's no factoring to do anywhere. Luckily, no GCFs or anything. So I'm just ready to rock. I'm going to do my vertical asymptote first. I'm going to set my denominator equal to 0. And of course, we're just going to solve that. I'm just going to add x over. So I'm going to have 2 equals x. I'm going to make it x equals 2 because I like it that way. I'm going to go ahead and draw that. Got it. And then that would also, if I asked, I'm not going to get crazy and write everything every time. If it asks for a domain, well, real numbers, x can't equal 2 because we're not going to hit that line. All right, horizontal. We're comparing the degrees. So degrees are our highest exponents on the variable. So I have x to the first, x to the first. Notice those are not in the correct order, that fraction. Really, it should be x plus 2, negative x plus 2, but whatever, just recognize I'm looking at the x to the first, x to the first. Now be careful here, because the order, I don't like the order. When the degrees are the same, it's the ratio of the lead coefficients, but it's not in the right order. So my lead coefficient on the numerator should be 1. The lead coefficient on the denominator should be that negative 1. Do I care if you reorder it? No, but just recognize what the first term should be. Okay, I'm going to draw that line. Yeah. Now, you can punch it in your calculator if you're feeling the urge, or I'm just going to make a little old school T-chart here. You can get the points off your calculator, I don't care. My asymptote, my vertical asymptote for x was at 2, so I'm just going to go on either side. I'm going to use 1 and 3. So I'm going to pick. All right, let's put 1 in for all the x's. So 2 plus 1 on the top, 2 plus 1, I got it. 2 minus 1 on the bottom. So I have the point 1 comma 3. And I'll draw the curve in a sec. I'm going to put 3 in. 3 on the top. 2 plus 3. 2 minus 3 on the bottom. So you have the point 3, negative 5. And that's, of course, enough to draw. I'm going to get close to my horizontal, close to the vertical, same thing. That's how it looks. And I don't care if you actually draw T-charts, mark or write out the T-charts. You want to just get that all from your calculator, you can. No judgment on that. Race have to be done drawing. And let's get excited for letter C. Ready for C? Okay, so here's what I'm excited for C. I'm like, ooh, fun, okay? What do you notice every single term in C has? What variable on it? They all have an X. So, that's key. We always want to simplify or reduce, of course, before we do anything. Like, I'd never leave anything as 2 for us, obviously. So I'm going to factor an X out of the top and factor an X out of the bottom. I know I'm being very dramatic about the word factor. You'll see why in a minute. Now, right away, before I cancel and simplify, and I'm going to do that all in a minute, I'm like, oh man, there is a common factor, which means you have a hole. So I'm going to have to, it's going to be great, my drawing skills, mark a hole in this graph. Get ready for that. Now, I will find it, we'll get to it. To find the hole, you set your common factor, which in our case is just X, equal to 0. There's no other expression with X, it's just X. And I will put an ordered pair down for it, and I'll get into all that in a minute. All right. Okay, so we're working off our red simplified rational function. All the same stuff. Vertical asymptote. I set my denominator equal to 0. All right, I'm going to solve that. Add 1, divide by 2. Who made this problem? A half? Come on. All right, let's try to draw x equal to half. Oh, gosh. Regretting that second iced coffee today. Well, that's pretty straight. Okay, all right. If I were doing domain, if it asked for domain, all real numbers, x can equal a half. And I might write out domain for this one, especially since we have a hole in it. All right, horizontal asymptote. Comparing the degrees. X to the first, x to the first. Okay, all right. When the degrees are the same, it's the ratio, fraction, of the lead coefficients. Well, the lead coefficient in the numerator 1, lead coefficient in the denominator 2. Great, good, another fraction. Pretty excited about that. Estimate it. Okay. All right, and we will mark the hole. We will get into that in a minute. Now, same thing, I'm going to make my T-chart. My asymptote for x is at a half. I'm going to pick numbers on either side. So at first I was like, yes, I'm going to use 0 and 1. But then I'm like, no, I'm not. No, I'm not. I am going to use 1. I'm going to lay off using 0 because that's where I'm going to have a hole. I do need to find that, and I will use it, but I'm going to hold off on that for right now. So instead of 0, let's maybe use like -1. So again, you can get the T-chart off the calculator. I don't care. I'm going to put 1 in. 1 plus 2, 3. 2 times 1, 2. So I have the point 1, 3. I'll use that to draw the curve. Okay. I'm going to put -1 in for x. -1 plus 2. 2 times -1, -2. -2 minus 1. Oh, that's fun. Okay, all these fractions, I'm real excited about it. -1, -1/3. Okay. Now, before I start drawing, because especially on the smart board, I mean, it's easier for you guys with pencil on your graph paper. It's very hard for me to like erase out a teeny tiny hole on here. So before I start drawing anything, I am going to go ahead and find the coordinates of it because I got to mark it on the graph grid and I don't want to erase it out. So I know my hole exists, 1, because you had your common factor. 2, you set your common factor to 0. So just like any time I need the y coordinate, if you know x, I'm going to throw 0 in for x. So I'm going to do 0 plus 2, so right on the side, 2 times 0, 0 minus 1. Okay, so at 0, -2, I have a hole. So this is easier for you to draw than me. So at 0, -2 on my little smartboard here, I'm going to try to draw the teeny tiniest little open circle. It doesn't look super open, but it is, it's open. And then of course I'm going to draw close to the horizontal. I'm going to leave that open, close to the vertical. Now, just to show you, you know, the love of math, if you want to see the hole on your graphing calculator, and I'm going to try to stay off my launch of Texas Instruments, although I can't promise anything here. If you want to see it, it's kind of a pain if you ask me to get your calculator to show it to you, but I feel I should do my due diligence and show it to you. So of course y equals, you have to put the original one in. If you do the simplified one, it's not going to show it to you. So I'm putting the original equation in. So alpha y equal, typing it in. I feel like I should have some Jeopardy music playing right now. 2x squared. Should see how slow I text. Let's see what it works. Okay. Just making sure I get it typed in right. Yep. Okay. If you hit graph, you can see this little tiny hole here. Well, it's not tiny. It's not tiny. If you hit like zoom decimal, zoom number 4, it kind of blows it up a little bit for you, and it's a little easier to see it. But you have to put the original expression in order to see the hole. And sometimes, depending on the graph, like it's so small you can hardly see it. So if you hit like zoom decimal, zoom number 4, it kind of refines it and will blow that up for you. I'm going to hit zoom 6 just so I'm back on my standard 10 by 10. But it's kind of a pain to get your calculator to show that to you. But I just wanted to show you. Okay, any questions on that? All right, let's give you some advice here, of course, just kind of simplify, summarize what we've got going before we hit our slant asymptote. So, as always, you are going to try to simplify your function. So that means, specifically, we're thinking about factoring. Now, you will see coming up, because like I said, they start asking you for like different stuff here. They're going to start also asking us for x and y intercepts. So I thought, well, let's throw that on here too. So if I, just like always, if you're on the x-axis, x-intercept. If you hit the y-axis, y-intercept. Okay, you know. Now, to find though, of course, just to get specific, if we're going to do it algebraically, if we're going to do the y-intercept, that's the easiest one, I think. F of 0. Because remember, that's what your x is. F of x, you're making x 0. So not on the next one, but the following one, they're going to ask for the intercepts. If they want the x-intercept, of course, we would use y is 0. Now think about this. Y is 0. Your function equals 0. We have a fraction. If I want my overall fraction to turn out to be 0, here's a shortcut for you. You just have to make the top be 0. 0 over 7, 0. 0 over 100, 0. So a little shortcut is you can just find the zeros of the numerator. Just set the top to 0. I mean, you can just make y 0 and go old school and solve it, but a little shortcut is just make the numerator 0 and the overall fraction 0. A little shortcut for you. All right, I'm going to draw the vertical asymptotes. I'm going to abbreviate here. I'm finding the zeros of the denominator. So we've done that. Then, of course, I did my horizontal asymptotes. By looking at the degrees, the exponents of the top versus the bottom. And really, the next thing basically is just make yourself a t-chart, okay? We're going to plot at least one point between and beyond our asymptotes. So that's just your t-chart. And of course, make smooth curves, blah, blah, blah. So they're going to start asking us for some other things on this, like some domains, some ranges, some x-intercepts, some y-intercepts, all stuff we know. But I just thought I'd do a nice little summary. Now, just because I can't help myself, and this was our first one with the hole, okay? I know it doesn't ask, I know. But if it asked you for domain, I just feel like I'm going to throw it on here. So if I'm looking at it left to right, the red, obviously, all the way left, all the way right, clearly we have the break at the green line a half. We know we can't use a half. But what other number can you not use for x? 0, because we have a hole there. So just be conscientious. Now you have 2 restrictions on what you could use for x, just to be aware. If, because, you know, the love of math, but then we need the range. So I'm like, okay, lowest to highest, lowest to highest. So this is going to go all the way down negative infinity. We got the asymptote, the blue line. I can't use a half. Red piece goes all the way above. So I'm like, okay, all right, got it. We can't use our asymptote, the blue line of a half. And what other number can we not use for y? -2, where the hole is, okay? So some of the domains and ranges look a little crazy of your restrictions when you have the point discontinuities. I know it didn't ask for that stuff on it, but I just can't help myself. It's going to start asking us for that. Okay, sketch the graph, a hand, check for intercept, and okay, answer this stuff pretty much. Okay, let's draw it. Now, as always, we try to simplify first. Right away, it jumps out to me, x squared minus 1, I can factor. Difference of perfect squares. I'm all over it. Oh, Common factor in the top and bottom, that x plus 1, x plus 1. So I'm gonna add a line here. Means we do have a hole in this guy. I'm gonna add that on. So let's cross these off. We're down to this. So I am gonna find it. I'm gonna get into it, but I'm just thinking right now, a little mental note, the hole exists when your common factor, which is x plus 1, we set it to 0. Yes, I know you can solve that. We'll solve it. We'll do all the stuff. We'll do it all. Now I'm looking at what we're left with. Okay, when I graph, I like non-function notation. Instead of f of x, I'm thinking that is y equals x minus 1. And I'm like, okay, I mean slope-intercept form. We got a diagonal line to draw. I can rock star that all day long. But because of my smartboard, it's hard for me to erase out where the hole would be on it. So I'm going to find it right now and mark it before I start drawing anything else. So I'm going to set this to 0. I'm going to solve it in my head, subtract 1. And then, of course, if I want the y coordinate, I'm just going to put -1 in there for x. I'm like, all right, -1 minus 1. Okay. So before I start drawing my mx plus b line, I know there's a hole at -1, -2. So I'm trying to draw a little open circle there because there's no way I could erase that tiny thing on the smartboard eraser. All right, we know how to draw a line. Slope 1, intercept -1. -1, so up 1 over 1, up 1 over 1. Okay, got it. My hole, got it. Let me give you a second to get yours drawn. This is not a trick question. What's the vertical asymptote? Do we have a vertical line stopping us? No, we don't have one. Do you have a horizontal asymptote? Do you have a horizontal line breaking up your line? Sure don't. But of course, we can answer domain and range. Okay, so domain, of course, x left to right. Well, my green diagonal line all the way left, all the way right, but we have this little hole, so I can use anything for x except -1. What's your range? You can use anything for y except -2, where the hole is. Got it. Okay. And of course, you might be asked, you know, the next problem is going to ask us x-intercept. Well, don't sweat it. It's right there at 1, 0. Y-intercept 0, -1. Don't sweat it. We'll get a lot of that stuff right off the graph. All right. We are ready to finally put our long division skills to use, my friends. Now, we might get to use synthetic. It just depends on what we're dividing by, but let's take a look at it. So 1, slant asymptote. We need to know when it occurs. It happens when the degree of numerator is larger than the denominator. So the degree of the top's bigger than the bottom, basically is what that's boiling down to. Now, here's the fun part. To find it, because of course our fraction bar means divide, we're gonna divide. Find by dividing. Now, I'm not gonna say long division because it depends on the divisor. You might get to use synthetic. And here's the other fun part for the slant, okay? The slant is a diagonal line. So you want an mx plus b form, which means we've seen when we do our division, you get some crazy looking remainders. We do not need the remainder. We are not using the remainder on these. So I'm going to put ignore remainder. We want an mx plus b style. Basically is what's going to happen here. All right, let's do a couple of slants. Now, last one for sure I'm going to use my calculator on because I don't even want to do the t-chart by hand and on the fraction stuff. You can touch a slant asymptote, and you'll see that in one of these graphs. You cannot touch a horizontal or vertical, just to be clear. Okay, here we go. Let's do it. I'm excited. Sketch the graph, by hand, check for intercepts, asymptotes, yada, yada, yada. Use your calculator, verify. Okay, so as always I'm going to check, can I factor anything and cancel? No, I cannot. Okay, great. So I'm going to start with what we know. Vertical asymptote, that's super easy. I just set my denominator to 0. Got it. That's not very exciting, but let's draw it. Okay. Now, clearly this one has a slant asymptote, not just because it's a blank on the line here, but we should know it has a slant because the degree of the top squared is larger than the bottom. So to find it, we have to divide these out. Now, long division works on everything. So I'm going to do long division on this one, just to practice, just to review. So I have 2x squared plus 1 divided by x. I'm just setting up my long division, and I don't care about the remainder. Once I hit the remainder, I'm going to stop. I want an mx plus b. So I'm like, all right, I got it. What times x is 2x squared? 2 and an x. And of course, we subtract. Hasta la vista. Okay, 1's the remainder. I don't care about it. I'm stopping. So I'm going to put my slant asymptote y equals, because we want an mx plus b, my answer up there 2x. So I'm going to draw out this diagonal line. Slope of 2. What's the y-intercept? 0. So I'm going to start at the origin, up 2 over 1, up 2 over 1, dash it. Dash that on. And again, your graphing calculator won't show this to you. Yes, I know it asks for intercepts, and yes, I will answer that. But I'm just doing all the stuff we already know how to do. I'm going to make my t-chart. You can get it off your calculator. My vertical asymptote's at 0, so I'm going to pick numbers on either side of 0. I'm going to use -1 and +1. Now, this one might not be a bad one to do the t-chart from your calculator just because there's so much computation that has to be done, but I'm going to do it. -1 squared 1 times 2, 2, 2 plus 1, 3. Then I have -1 on the bottom, so I have -1, -3 there. 1, 2, got it. Okay, so close to the vertical. Oh, baby, I got a little close to the slant. So it's a little curved job there. Let's put 1 in. 1 squared 1 times 2, 2, 2 plus 1, 3 over 1. So I have 1 comma 3. Got it. Close to the vertical. Got it. Okay. And again, you can get the t-chart from the calculator out here. Now, this is why I personally always save the intercepts for last. Even though it's kind of at the beginning of, us learning how to do all this. Because I'm like, oh, well, I'm just going to look at the graph. Does my blue curves are the actual graph, do either of my blue curves touch the x or y axis? So I don't have any. Yay, none. That's why I kind of always save them for last. Most of the time, you can just get them from looking at your graph. You don't have to get crazy and do a whole bunch of algebra. All right, last one with a slant, and this is my favorite one. We're going to do this one off the calculator a little bit too to help us. All right, as always, I'm going to first check, can I factor and cancel? Well, I mean, I could pull a 2 out of the bottom, but there's not a 2 on the top to cancel with, so it's not going to really get me anywhere. So, I mean, even if I take the 2 out, I could factor down then x plus 2x minus 2. There's nothing to cancel with x cubed, so I'm not going to waste my time. All right, let's do what we know. Vertical. Set the denominator equal to 0. All right, okay, let's solve it. I'm going to add 8. I'm going to divide by 2. And I'm going to root it. Ooh, fun. How many vertical asymptotes do you have? 2. So plus or minus 2 I'm going to put. Okay. All right. Draw both of them. This is why this one's my favorite. Okay. All right. Clearly it has a slant asymptote because, well, there's a blank on it for this one. Also, we should know our degree of the top is bigger cubed versus squared. Now, we got to divide it out. Could you use synthetic division if you wanted? No, because our divisor degree is a squared. Remember, synthetic only works if your divisor degree is a 1. So even if I wanted, I got to use long division. So I got x cubed divided by 2x squared minus 8. This is going to be a good one. Just for drama, I'm going to put a coefficient of 1 on there. Because you, my friends, are going to have to figure out what fine fraction, multiplies by 2 to get you back to a 1. What fraction is it, Elliot?
I have 1/2 x, but x over 2 also.
I like it. And, I mean, is that awful? No, we should be able to deal with a half. That's as wild as the fraction work gets, okay? Half times 2, 1. Half times negative 8, negative 4. Of course, we're going to subtract. Guess what? Here's our remainder. We don't care about the remainder because we want it mx plus b. So I'm going to put my slant y equal 1/2 x. So I'm going to mark that. Y-intercept 0, up 1 over 2 for some slope action. 0, up 1 over 2. Got it. Kind of like adult coloring. It's therapeutic drawing those on. Now, I gotta be honest. I don't know if I really want to do the T-chart by hand because I'm like, dang it, I'd have to put a number in on the far left, something in the middle, something on the right. I gotta cube it, square stuff. It's the end of the day. We're tired. God bless technology. Let's use our graphing calculators here. So let's pull that up. Just click on it here. Maybe. Come on, smart board. Okay. So I'm going to do my alpha y equals, of course. Just so that way I don't have to use parentheses or worry about messing that up. X cubed, 2x squared, minus 8. So remember, your calculator will not show you the asymptotes. You have to be able to get those on your own. Now, we've got the 3 different blue curves, so we're going to draw those on here. I'm not going to get carried away. Let's see what we got for points, if we got anything decent. So I'm looking for something negative. Okay, I'm going to try that -3, -27/10, -2.7. That's -2.7. I'm going to estimate it. -3. Close enough. Okay. There's that one. Okay. 0, 0. Let's use 0, 0. Which remember, you might be like, oh my God, 0, 0. You can touch a slant. You can't touch a horizontal or vertical. Now, I'm just going to kind of look at the graph here. I'm not going to try to mark 1, 6. Let's get real. So I curve to the left, curve to the right. Okay. And then we're going to get a final positive answer off here on the right side. Obviously not 2 because we have the error because our asymptote. I'm going to do, too far. Let's do like the 3 and the 27/10 or 3, 2.7. Yeah. Okay. All right. Now, haven't gotten carried away with a lot of algebra. I don't want to get carried away with a lot of algebra if I don't have to. Can you look at the graph and tell me where it hits the x-axis and the y-axis? 0, 0. Yep. Make your life easy, hits at the origin. Now, I know, final thing, we have the time for fun. What if it asked you, like, for domain and range? X can equal 2 and, okay, like it. Okay, let's do range just for fun, so. What's your range? Remember, range, y-axis, lowest to highest, and factor in all 3 of those red pieces. You're gonna cover everything, right? Because I'll give you just the middle. If I ignore the others, the middle takes you all the way down, all the way up. So between all of them together, I don't know why I have a semicolon, it's just gonna be all real numbers. Just for fun. And you'll see on the homework too, like some will ask you domain, some ask you range, some ask you to write the intercept.